Good morning, everyone. Welcome to today's hearing. Today we're going to hear evidence from Mr. Granville Partlow, who commissioned the smoke control system at Grenfell Tower. Yes, Ms. Grange.
Yes, thank you. Can we call Mr. Partlow, please?
Thank you. Good morning, Mr. Partlow.
Good morning.
I understand you're going to make the affirmation.
Yeah.
So could I ask you please to read the words on the screen in front of you?
Yeah. I do solemnly, sincerely and truly declare and affirm that the evidence I shall give shall be the truth, the whole truth and nothing but the truth.
Thank you very much. Now do sit down, make yourself comfortable. There's some water there if you want it. All right?
Yeah.
Good. Thank you very much. When you're ready, Ms. Grange.
Yes, thank you. Yes, good morning, Mr. Partlow. Thank you very much for coming to assist the inquiry with its investigations. It's very much appreciated. I'm going to be asking you the questions today. If you have any difficulty understanding anything I'm asking you, please just ask me to repeat the question or put the point in a different way. And also, can you keep your voice up so that the transcriber lady who's just sitting to your right can take a nice clear note of your evidence? Now, you've made 2 witness statements for the inquiry. Can I take you to the first one? It's at PSB 401309. There's the statement. And if we look at page 26, we can see it's dated the 28th of September 2018. And is that your signature?
It is.
And have you read that statement recently?
Yes.
And can you confirm that the contents are true to the best of your knowledge and belief?
They are, yes.
Thank you. And if we can now pull up your second witness statement, that's PSB 401372. There's that second statement. And if we go to page 9, we can see that's dated the 26th of March 2021. And again, is that your signature?
It is.
And have you read that statement recently?
I have, yes.
And can you confirm that the contents are true?
To the best of my knowledge, yes.
Thank you. And have you discussed the evidence you're going to give with anybody before coming here today?
No.
Thank you. Now, I'm going to start by asking you some questions about your qualifications and experience. If we can look at your statement, your first statement at page 2, you've set those out at paragraph 6 through to 8. You tell us at paragraph 6 that you're a qualified electrician and electrical engineer. Over the last 40 years, you've worked in various industries, including mines and quarries, metal fabrication, plastics and the chemicals industry. And you've held positions as an electrical engineer and commissioning engineer, both electrical and mechanical, as well as several managerial roles. Is that correct?
It is, yes.
And then you've set out your qualifications for us at paragraph 7, including various city and guilds qualifications and diplomas. And we can see in the middle there's a City and Guilds diploma, third bullet down, in advanced pneumatic systems, and one in advanced hydraulic systems below that. And then in paragraph 8 at the bottom of the page, you say you've got experience of using various programming, including AutoCAD. And over the years, you've attended courses on various software, workplace organisation, investors in people and team building. And you say you hold various safety cards and that you're a member of the British Institute of Managers. Is that correct?
It is. I'm not a member anymore, but yes, I used to be.
Thank you.
Yeah.
Now, we'll come to your experience and job roles in a moment, but focusing for now on your qualifications, to what extent did any of these qualifications relate to smoke control systems and the commissioning of those systems?
The electrical qualification and, to a small extent, the pneumatic and hydraulic systems are all part of flows, so they're similar to ventilation systems.
Yes, I see. And have you received any specific training on commissioning smoke control systems?
From the experts that work for the company and working alongside them. Yeah.
But no other form of training or qualifications?
I don't think there is any.
No, I understand. Let's go now to paragraphs 9 and 10 of your first statement on page 2. And this sets out your work experience or your work history. You tell us at paragraph 9 that you started working for what is now the WIT UK group in 2005, and that group is made up of 4 companies: PSB, WIT, Sun UK Limited, WIT and Sun Properties Limited, and WIT and Sun Holdings Limited. And you say initially you were employed as a works engineer, and that you've been commissioning and servicing smoke control systems since about 2006. Is that correct?
That's correct, yes.
And then in paragraph 10, you explain your employment experience before you began at WIT. You say prior to working for that group, you were an industrial engineer for the Bradbury Group, where you were responsible for, amongst other things, modernising production lines in their factories. And before that, you spent 14 years in the plastics industry, working in a variety of roles, including an electrical engineer, maintenance manager, and production manager. So is it right that before you began working for the WIT Group, you hadn't previously worked on smoke control systems?
That's correct, no, I hadn't.
Yeah. Now, turning to your role with PSB and WIT more widely, if we look at over on page 3 of your first statement, paragraph 11, you explain that in your role as Group Service and Engineering Manager, and that was your position in 2016 when you commissioned the Grenfell system, is that right?
It is, yes.
Yeah. In that role, you say you were responsible for the day-to-day running of the service department for all of the companies within the WIT UK group. And you go on, typically my role involved commissioning and servicing a variety of products that were designed and installed by one of the companies in the WIT UK group or by another company. The products I commissioned and serviced included all forms of smoke ventilation, extraction and control systems. Is that correct?
It is, yes.
So would those be smoke control systems and like environmental extraction and control systems?
Yeah, they could be both.
Air conditioning systems?
Not air conditioning as such, but ventilation.
Yes.
Car park and tunnel extraction systems, smoke clearance, and then above ground, which is residential or office buildings.
Yes, thank you. And then at paragraph 12, you say, more recently, my role has changed slightly and I'm now more involved in the sales of WIT UK Group products, although I still oversee commissioning and servicing and regularly carry out commissioning and servicing of systems. Now, later on in your witness statement, I don't think we need to turn it up now, but for the transcript, it's at paragraph 136. You say that you had commissioned countless systems over the years. That's a comment that you make in the context of your evidence about the fireman's override switch at Grenfell Tower. We'll come to that aspect of the system later. But I just want to ask you about your general experience of such systems. I know you say countless systems, but could you just estimate for us how many smoke control systems you were commissioning per year, for example, say in 2016 itself, approximately?
Combined car parks and above ground systems, probably 20, 30.
Yeah,
Yeah.
that's helpful. Now, prior to your work commissioning the Grenfell Tower system in between February and April 2016, what experience did you have of commissioning smoke control systems in residential high-rise buildings?
Well, I'd been commissioning in above ground smoke control and car park systems since about 2006, 2007, initially working alongside the company smoke specialists and mainly being involved in the control side of it.
Yeah.
So the electrical and mechanical side rather than the system side. And basically that had carried on from that date.
Yeah. And what proportion of that work, that above ground work, was on residential high-rise buildings, would you say?
Probably 15%, 10%. High-rise, I'm suggesting 10 floors or above.
Yes.
Yeah.
Okay. You think 10 to 15% of your work would have been high-rise, i.e. above 10 stories?
Yeah.
Yeah.
Possibly more, but I have
Yeah.
to guess.
And how much, just in general terms, how much do such systems vary from domestic building to domestic building? Are they often very variable, the systems you have to commission?
They vary slightly, and obviously building to building they vary depending on lengths of corridors, what type of corridors, whether they're L-shaped, T-shaped, whatever, whether it's a push-pull system, a true reversible system. So there's different types, whether it's a pressurised lobby or depressurised lobby system.
Yeah.
So there is a fair variety,
Yeah.
but it's a limited variety.
Yeah. And how much experience had you had prior to the Grenfell Tower project of commissioning a mechanical extract system using pressure differentials?
Probably, of the above ground systems we did, 50%.
So 50% of those were mechanical pressure differential systems?
Yeah, so they're
Yeah.
firefighting lobby extract systems.
Right.
So there's no corridors as such, it's just a lobby.
Yeah. And what experience did you have of commissioning systems which had a dual smoke control and environmental function? Was that a common feature of your work?
No, it was probably 1 in every 10 or 15.
Yeah.
Yeah,
So that was more unusual, was it, to get a combined system?
yeah, because
Yeah.
they don't generally work.
When you say they don't generally
The
work?
environmental side,
I see.
if you're trying to cool a little lobby down and your outside ambient is, say, 29 degrees, best you're going to cool that lobby is to, say, 26,
Right.
which is still too warm.
Yeah. Okay. What about the smoke control aspects of combined systems? Do they normally work?
It doesn't affect it. It's
Yeah.
entirely separate.
Yeah. Now, in your experience, how typical was the Grenfell Tower system as a smoke control system for a residential high-rise building?
It was a bit of a one-off.
A bit of a one-off. Had you ever come across anything like it before?
Well, similar, yeah, because it was a depressurised lobby system, so it's quite often used more commonly in office blocks, commercial buildings, rather than residential.
Yeah.
But the kind of system that was used, negative pressure within that lobby to protect the stairwell, is quite a common kind of system.
Yeah.
But Grenfell was governed by what it had available to use, basically.
Yeah. And that's why you initially said it was a bit of a one-off. Is that right?
Yeah, and it normally we would be commissioning in a new build or a new building that's empty.
Yeah.
So you would probably go in there and be 3 to 4 days, to do 10 floors, say.
Yeah.
Whereas with Grenfell, it was done in bits and pieces. So the initial pre-commissioning was done from floor 4 to 23.
Yeah.
Then we did floor 1 and floor 2.
Yeah.
And then eventually we went back and did floor
Yes,
3,
thank you.
etc.
Yeah. I'm going to come on to that in a moment about the stages in which you took the Grenfell work, but that's very helpful, thank you. Do you still work for PSB?
Yes,
on the
I
WIT
do.
group? You do?
Yes.
Yeah. Now let's turn to your work at Grenfell Tower. If we go to paragraph 17 of your first witness statement on page 4, you explain that PSB was instructed to provide commissioning services to JS Wright by way of purchase orders dated the 21st of January 2016 and the 26th of January 2016. Now, just in general terms, what was your understanding of the purpose of commissioning the system? What was it meant to achieve?
To correctly identify all the component parts,
Yeah.
to ensure that all of those parts were connected to the correct control system on each level, to ensure that all those different bits and pieces that comprised the system worked as designed, and then eventually to, once everything had been tested, to make sure it operated according to the cause and effect.
Okay, thank you. And we'll come back to that cause and effect document in due course. In general terms, can we agree that the key purpose of commissioning is to demonstrate that a system can adequately perform the functions for which it was designed?
Well, that's the general idea, yes.
Yes, thank you. Now, if we go to paragraph 13 of your first statement on page 3, you tell us there that you attended Grenfell Tower between a variety of dates. So you attended on 2 occasions in February, 3 in February, then in March, and then in April 2016. So you give us the days, and you attended 3 days, 5 days, 4 days, 4 days, 3 days. So that's where you said earlier that it was done piecemeal, if you like. Is that correct?
Yes, basically.
And you're saying there in that first line that you attended on those dates to commission the system. Now, I'm going to come to your use of the word commission in that paragraph in just a moment. But just before we get to that, who directed you to attend Grenfell Tower, to undertake this work at the tower? Who instructed you to do the work?
The project manager.
And who was that project manager?
David Harrison.
Yeah. And what involvement, if any, had you had with the Grenfell Tower project prior to this point, so prior to attending on the 3rd of February 2016?
Very little. I was asked would I be able to attend before Christmas, which was to see if they could activate the system in some way over Christmas, which I said no, it can't be done.
Yeah.
And then probably the week before I first attended site, I would have been given a commissioning pack by the project manager, which would have had, it would have been basically a folder, would have had all the drawings in, all the relevant documents required, copy of the cause and effect, etc. I would have also have downloaded a full set of those drawings onto my laptop, so I could take them with me as well.
Yes.
And the software, obviously.
And was that a typical process for you in the commissioning role, that you would just get a brief just a few days before commissioning the system? Was that the normal way it worked?
Generally.
Yeah.
Maximum I would have had knowledge of it would probably be about 2 weeks before.
Yeah.
Because obviously they'd fill my calendar with the different buildings I was supposed to attend over that period.
Yeah. And just to be absolutely clear, I think I know what your answer is going to be, but did you have any involvement in the design of the smoke control system at Grenfell Tower that you were commissioning?
No.
No. Did you actually speak to any of the designers of the system within PSB before you attended Grenfell Tower on that date?
Not that I can remember, no.
So you didn't get any kind of briefing by a designer of the system?
The designer, which was Mr. Marnie, I think he'd actually left the company before we actually started the commissioning anyway.
Yeah.
So probably, a brief chat with David at some point prior to going to site, just so as he could give me a bit of information about the site, where it was, what it involved, but it had been just a brief outline.
Yeah. Now, if we can go now to paragraphs 4 to 6 of your second statement at page 2 of that. And you tell us this in paragraphs 4 to 6, and it's headed Terminology of Commissioning. In paragraph 13 of my first statement, I said that I attended Grenfell Tower to, quotes, commission the system on dates between February and April 2016. I now appreciate that the word commissioning may have different meanings to different people. I used the word to encompass all of my activities on site associated with testing and commissioning the system. As I was asked to attend site to check and test components of the system on numerous occasions as it was being installed, it may help to clarify my use of the word commissioning in my first statement. And then at paragraph 6, you go on to say, my visits to Grenfell Tower in February 2016 were to check the progress of the installation of the system and, where possible, test the functionality of the components which had been installed. I was not commissioning in the strict sense the system in line with the performance criteria at this stage. Obviously, I could not confirm that it was a viable system until construction was complete. So there you have helpfully clarified that your visits in February were to check the progress of the installation and, where possible, check the functionality of installed components, but you were not at that stage commissioning the system. Is that correct?
Yes, that's correct.
And you go on to tell us, if we can move down the page at paragraph 8, you tell us that your interim report that you produced, dated the 28th of February 2016, following those February visits, was not intended to be used as evidence that the system had been fully or partially commissioned. Is that correct?
That's correct, yes.
And picking it up in the 4th line, you say the report just demonstrated that certain elements of the system had been tested and were working, rather than being able to say they were commissioned. I included the following comments to make the limitation of my report clear. And you say that you wrote in the report, this is not a full commissioning report. It covers floors 4 to 23 only. To complete the commissioning, floors ground to 3 will need to have all builders' work complete, including floors fitted and vent shafts sealed. Volumetric readings can only be taken when all builders' works are complete. So it would appear that the position was that when you attended in February, there were still works going on to the lower floors. Is that correct?
Yes, that's correct.
And that's why you couldn't commission the whole system?
Yes.
Yes, I understand. Now, just looking back then at paragraph 13 of your first statement on page 3, you've told us that the February dates were not for the purpose of commissioning. That's the first 3 bullet points. Can we just be absolutely clear? Does it follow from what you've told us that the March and April visits that you undertook to the tower were for the purpose of commissioning the system against the performance criteria?
It would have been partially that, but it was not. It wouldn't have been complete because the existing entrance level, which became level 2, I think, yeah, wasn't completed until just before I went back in the April. So we still would not have been able to complete the full system. What did happen is the dampers on that level were closed, and it allowed us to take some volumetric readings on other floors. But we never took the full set of readings until the April, I think it was.
I see. But are you saying that in April, in those 3 days between the 26th and 28th of April, the whole system was finished and you were able to take complete readings, including from level 2?
Yes.
You were, yeah. So, as far as you're concerned, you did actually complete the commissioning of the system, did you?
In April, yes.
In April,
yes.
Yeah. Now, let's go to PSB 50802 now. Yes, this is an email dated the 9th of December 2015. It's from David Harrison of PSB to you. We can see that at the top. And he's forwarding an email sent from Hugh Marney to Jonathan Earl of JS Wright with a breakdown of PSB's proposed commissioning work activities. So you can see below, you've been sent an email that just says heads up. And then below that, Hugh Marney from December 2015 had sent JS Wright, copying in some others at PSB, an email which said, we anticipate having a pair of men on site for just under 2 weeks and our price includes board, lodge and travelling. In addition, upon completion, test certificates and compliance documents will be provided. Basic breakdown of our commissioning work activities as follows. We have to take readings on every floor for both smoke ventilation and environmental ventilation. And then if we just scroll down that page, we can see a list of commissioning activities linked back to the cause and effect checklist. Can you see that in that
Yes.
email? Now, had you seen that list before you first attended Grenfell Tower?
Well, if it was if I received the email, then yes, I would have seen
Yeah.
it.
Do you remember seeing it?
I don't really remember seeing it, but I would have definitely seen it.
Was this a standard PSB document setting out the stages of commissioning work activity?
I wouldn't say standard. It was specific to Grenfell because of how the system was designed.
I see, yeah. Now, in paragraphs 18 to 23 of your first witness statement, you explain that before your first attendance at Grenfell Tower, you had a number of documents, and we can see that the first document you mention, if we go to your first statement at page 4, just to remind you of this section of your statement, and look at paragraph 18. So you say, before I attended Grenfell Tower, the following principal documents were provided to me. That's at paragraph 18. And you say at 19, a copy of the PSB commissioning method statement and risk assessment dated February 2016 and provided to Alan White of JS Wright on the 1st of February 2016. Now, who was the author of that commissioning method statement and risk assessment?
Well, without seeing it, I don't know. I know I did an updated risk assessment, whether that's the one.
Yes, let's look at it. So it's PSB 50941. There we go. That's the PSB commissioning method statement and risk assessment for Grenfell Tower. It's dated February 2016. And we can see PSB's logos at the top. And if we just look on within it, just to refresh your memory, there we can see the contents page. If we could move down the pages, the revision history, scope of works, etc. Do you see that?
Yes, I do, yeah.
Now, does that help you remember who was the author of that document?
That is probably the one that I did.
Yeah.
Yeah.
And can you help us? What was the purpose of the method statement and risk assessment document? What was its main purpose?
Prior to going on site to carry out any works, the main builder, the MEP company, would expect a method statement, and it's mainly really not so much, it's a brief outline method statement of how you're going to commission the system, but it's more from a safety point of view.
Right.
And COSH, you know, are you going to be taking any chemicals on site or anything like that could be hazardous or dangerous. This particular statement, I was asked, this particular method statement, I was asked to prepare it and send it just a few days before I was due on site for commissioning.
Yes.
Normally, it would have been done by either myself or the PM that was running it.
The project manager.
Yeah, the project manager,
yeah.
Which was David. On this occasion, I don't know if David wasn't available, but I did it. But basically what I did is I was in a hotel and they wanted it for the following day. And I think I emailed another colleague from the company to send me a generic method statement out, which I then amended as best I could quickly.
Yes.
To send it out to the client so they'd have it prior to me arriving on site.
Yes. Thank you. That's helpful. I can actually I'm going to take you to the emails where you're being asked for a method statement, and then the emails where you request a precedent for that from your colleague. So we'll just come to that. Just before we go to those email exchanges, if we look at paragraph 11 of your second statement on page 3, you say the circumstances in which this document came to be produced are explained in email exchanges provided to the inquiry. It was produced by me at a busy time. It contains errors and does not accurately reflect the system. Is that right?
Yeah, basically.
Were you aware at the time you actually prepared the document that it contained errors, or are those errors something you've spotted subsequently?
The errors were made mainly through me doing it at a busy time. And no, I didn't notice them when I did it, but afterwards, when it were pointed out, yes, obviously.
Yes.
It was basically the description of the system that was wrong, the type of system.
Yes, and can you help us, why did you not explain in your first witness statement that that document contained errors which you were aware of?
Because until I'd read it a few times, I didn't appreciate I'd made the mistakes I'd made.
I see, I understand. So let's look at the emails that you're referring to in that bit of your statement. If we can go first to PSB 50917. This is an email dated the 29th of January 2016 from David Harrison to you, forwarding an email from JS Wright. If we look at the email below first, we can see that Mr. White of JS Wright has said to Mr. Harrison and Mr. Marnie, "Hi David, can you help me out with a commissioning statement? This is being requested from our client and would also help me understand your intended methodology. If you have any outstanding queries or concerns, please shout now." So that's 28th of January 2016. And on the day later, Friday the 29th, David Harrison emails you and says, "Granville, do you have a standard commissioning procedure?" Do you see that email?
I do, yes.
And we don't see any response to that email, but then if we go to PSB 50396, PSB 50936, sorry, that was me saying it wrongly. Thank you, sorry. If we look 3 emails down on this page, we can see that on the 1st of February, Mr. White of JS Wright has sent to Mr. Harrison and Mr. Marnie another email saying, "David Hugh, our client needs to see a commissioning statement detailing what will be carried out, when and why. Issuing info will also benefit yourself, as I will have the detailed knowledge required to assist the smooth running of your works. I have been asked to issue this no later than the 2nd, prior to commencement. Could you have it over to me by the end of play today, please?" So you can see that JS Wright are chasing for that commissioning method statement. And then in response, 1 email up, we go up the page. David Harrison emails you at 7:35 on the 2nd of February, so the next day, saying, "Hi Granville, this guy keeps pressing. Can you draft something just to keep them informed, David?" Now, what did you understand him to mean by just to keep them informed?
Basically, that they wanted a method statement before I attended site, so that they'd have some idea of how I was going to carry out the commissioning.
Yeah.
And what safety aspects, etc.
Yeah. Was it PSB's normal practice to provide a method statement before attending site?
Yes.
It was?
Yes.
And can you explain why it hadn't been done prior to these emails being exchanged?
I used to do some of them. The project managers used to do some, depending. Basically, I was on site all the time and just didn't get a chance to do it.
Yeah.
So then it got to the point where they were wanting it like the following day. So that's why I asked for a copy of one from elsewhere, so that I could basically just adapt to suit, so that they'd got something to work with.
Yeah.
I mean, it's not going to be 100% accurate, because until you start commissioning, you don't know what's going to happen on any one day.
Yeah.
So it's a broad outline of how you're going to carry it out safely.
Yeah. But, I mean, had it just got forgotten, or did you know it was outstanding but you were just busy?
I didn't realise it was outstanding. I just assumed David would have done it.
Yeah. And then at the top of the page, we can see your response at 10:13, where you say back to Mr. Harrison, "I will struggle to get it done as I'm at a site today and tomorrow, but we'll see what time I have to spare later. Just a thought, Tim mightily have something on file if you'll want to give him a call. Here could have sending it to me and I could adapt it." So I think that's you asking for a method statement from another job, is that right? So that you can adapt it?
Yeah.
And who was Tim?
Tim Haig, he was the contracts manager with the company at the time.
Yeah. And the word mightily, what did that mean in that email?
That's me just typing wrong.
Oh, I see.
I'm doing it on a Samsung phone and I've got big fat thumbs.
Thank you.
It looks to me as though you've been the victim of the auto-complete
Yeah, predictive text.
predictive text. Exactly.
Yeah. And can we take it from this that PSB didn't have a standard commissioning method statement document detailing what testing would be carried out at this point?
Yeah, because each job is different because, the number of floors changes the method statement, whether it's corridors, whether it's a lobby, whether it's a depressurised system, a push-pull system, a reversible system. So each statement is it's a one-off for that particular building.
I see. So does that mean that every time you did one of these method statements, you had to write it from scratch, or were there any kind of guides within PSB?
Not from scratch. You would take a similar method statement from a similar job and then change it to suit, i.e. number of floors, job number, building reference, building name, location, type of system.
Yeah. And then if we can move on with the emails, if we can go to PSB 50938 and look at the foot of the page, we can see this is an email from someone called, this is the Tim, is it? Tim Hay.
Tim Hay.
At PSB. That's PSB's contract manager, we understand, to you later on the 1st of February 2016. The subject is RAMS. Is that risk assessment method statement?
Yeah.
And he says, attached is RCA method statement. You may be able to adapt. Yes? Now, can you help us? What was the RCA method statement?
RCA is the Royal College of Arts, Battersea, and it's another job that PSB undertook on 2 occasions on 2 different areas of the college where we installed smoke control systems. It wasn't an exact match for Grenfell because, RCA were probably 6 or 7 floors. Grenfell's a lot more, and it was more of a corridor system rather than a lobby system at Royal College. But it's nonetheless, it's got all the basic characteristics of what safety procedures you're going to adopt. It's all to do with like working at height and various things. It's not just the methodology of how you're going to commission it. It's a risk assessment as well combined.
Yeah. And then we can see your response at the top. You say to him, thanks, should do nicely. And if we go on within these email chains to PSB 50941, we can see your email at 14:05 at the bottom of that page, an hour and a half later, to David Harrison with the risk assessment method statement, who then forwards it on to JS Wright. We can see that then at the top of the page. He says in the second line, hi Alan, RAMS for commissioning as requested. So I think, as you've explained, you adapted that method statement from the Royal College of Arts one. How did you do that? Did you just edit it?
Yeah.
Edit the document? Yes.
Just edit it, copy and paste.
And we can see that the email was sent 1.5 hours after receiving the RCA one. Can we take it from that you didn't spend more than 1.5 hours on it?
Well, probably.
Can you recall how long you did spend adapting it?
Probably about 1.5 hours.
Yeah.
I would have started modifying it as soon as I got it.
Yeah.
And then once it was finished, sent it out to David.
Yeah. And at the time, did you think you'd given enough time and attention to that document?
At the time, yes.
Yeah. And looking back now, does the fact that you adopted this other RCA statement as your template rather than preparing your own from scratch, does that account for some of the errors that you've now acknowledged in it?
Most probably.
Yeah.
Yeah.
Now, if we can go to section 13 of that PSB method statement, so this is PSB 50941, and I want to look at page 11. At section 13, we can see there is an inspection and test plan, that's the heading at the top of the page, with a list of tasks. And it says underneath, before PSB can commission the system, all the points below must be confirmed as 100% complete. And we've then got a list of tasks. For example, under installation, it says, ensure all the ventilation system equipment has been correctly installed and connected, visually check there's no damage to equipment, have all control panels been correctly installed and connected. So was that effectively a checklist of installation tasks that needed to be completed prior to commissioning?
Yes, basically.
And is it right that although the document lists the tasks that must be completed as part of installation and then commissioning, nowhere do we see within this commissioning method statement anything about which specific standards or guidance documents were relevant to that commissioning process which were going to be used? Is that right?
That's correct, yes.
Did you intend to carry out that commissioning process in compliance with any particular standards or guidance documents?
It would have been carried out with 101.2 part 6. I think there's about 8 or 9 tests that have to be done on a depressurised system.
Yeah.
Combined with Smoke Control Association's guidelines,
Yeah.
probably bits of approved document B,
Yeah.
because it was an hybrid system. It wasn't a true depressurisation system. It wasn't a true mechanical vent system.
Yes.
It was a mixture of the two.
Yeah.
Well, it became a mixture of the two to try and give the desired outcome of protecting the stairwell.
Yes, I understand. And can you just explain why you wouldn't list the guidance documents that you were going to use to test the system in this commissioning method statement?
Normally, the guidance used would have been in the technical subs that were issued initially with the project.
Yeah.
In the commissioning, the RAMS is more from a safety point of view. It's not an exact and precise document for how you're going to commission it on a day-to-day basis, because you can't possibly do that.
Right.
I mean, I commissioned this tower over 19 days.
Yeah.
I couldn't foretell what would happen on day 3, day 7, day 9. So it's a generic list of items that you would check.
Yeah. Thank you. Now, if we look at paragraph 13 of your second statement on page 3, you say in this part of your second statement, none of the inadequacies in the method statement hindered my understanding of the system or what I was required to do in undertaking the commissioning exercise on site. And then you go on to say in paragraph 14 that in fact you used other documents as your reference guides when undertaking the commissioning exercise, not the method statement. We see that particularly clearly in that last line, or that last few lines of paragraph 14. So is that right, that you didn't really rely on the method statement when you were commissioning, you relied on other documents?
Yes, the documents I would rely on would be initially the 800 drawing, to some extent the commissioning, the RAMs, obviously, to make sure I didn't do anything different to what they were expecting.
Yeah.
As a guide. And then the panel drawings, the board assignment drawings, etc., and the cause and effect are the main documents I would use.
Yeah. Now, turning back to your first witness statement at page 4, paragraph 20, you tell us that the second document you used, that you were provided with, was something called PSB E800 Electrical Schematic Rev E. Can we just look at that? That's PSB 50429. So if we could just maybe rotate it round. Now, we don't need to read the detail of this drawing, but can you just explain in general terms what was the purpose of this document, this electrical schematic?
That electrical schematic lists all the items that are connected to the control system on each level, what the items are, what they do as such, and I would use that effectively as a tick sheet. So depending what level I was working on, I would work out from the outstation and look at every item that was connected on that outstation. So the north and south shaft dampers, the pressure detector, the fireman's override,
Yeah, yeah,
etc.
yeah, I understand. And is it right, therefore, that this document showed where each of the smoke control components was and how the system was wired together?
Yes.
Yeah. And just to be clear, did you actually make use of that document during the commissioning process?
Constantly.
Yeah.
All the time.
And was this a typical schematic for such systems?
Yeah.
Yeah.
As far as schematics are concerned, yes.
Yeah. Now, going back to paragraph 21 of your first statement on page 4, the next document is called, we can see at the top of that page, the panel and outstation data for the job, which you say in the second line, which you refer to as the board assignment sheets.
Yeah.
If we can go to that document, this is PSB 401256. Now, again, can you just help us? What was the purpose of this document, this panel and outstation document?
That particular one is for the master panel, and it tells you on the X numbers, X31, X312, etc., what is or should be connected onto those two connections. So if you're just looking at the first one, it's terminal rail X3, terminals 1 and 2. It goes to the pressure switch. The switch is identified as being PS1.
Yeah.
And it's 24 volt output, and then you input back into the control panel.
Yeah. And in simple terms, did this effectively explain how the electrical components were designed to work and how they linked together?
Doesn't explain how they were designed to work, but it does explain how they were linked together.
Yeah.
So I would use that to ensure, in conjunction with the 800 drawing, to ensure that PS1, FOS1, SDE1, PS2, etc. were connected to the correct connections within that panel, and that they were connected to the correct dampers, switches, pressure detectors on that level.
Yeah, thank you. Yes, thanks. And then the fourth document, if we go to paragraph 22 of your first statement, page 5, is you refer to as the PSB fans and damper operation cause and effect chart. Now, you've mentioned this cause and effect chart, I think, already in your evidence. And if we can pull that up, this is at PSB 50232, and we may need the native version. That may work okay for our purposes. So this is the cause and effect chart, is that right?
It is, yes.
And again, in general terms, can you just explain what this showed?
You make it a little bit bigger. That shows, for example, if you just look at the first column, which says ground floor, and it says it's fire zone 1, and if fire zone 1 activates, damper 1 and damper 2 will open. So that's telling me if you activate fire zone 1,
Yeah.
that's the dampers that will open. And if you carry across on that top line, everything else is shown as closed. When you get to where the fans are, it tells you what speed the fans should be running at.
Yeah. So I think the fans are in the second table.
They're on the lower side, yeah.
On the right-hand side, we can see fans, floor 2 and the roof. And it tells us, we'll come to this in a moment, whether the fans are running at 100% or off. Is that correct?
Yes. Well, 100%, and under pressure detection, they drop down to the lower speed.
Yeah. Now, who prepared that document? Do you know?
I would imagine either you or the CAD designers. I'm not sure.
Either Hugh Marnie.
Yes.
Or when you say the CAD design.
Well, the design team prepare
Right.
lots of all the different documents, like the drawings,
Yeah.
the 800, the board assignments are provided by the control panel people, etc.
Yeah. Were you responsible for checking that it was an accurate document for use at Grenfell Tower?
Well, yes. I would have to make sure that it made sense, if anything else, yes.
And does this document describe how the system's fans should operate on every floor of the tower in both smoke mode and environmental mode?
It doesn't. It does show the environmental fan, EF whatever it is, I believe, but it doesn't. It just shows it as being off, because this is relevant to the fire mode, so fire detected.
I see. I see.
And I'm not sure if at the bottom of that page somewhere it might mention that if the pressure switches are operated, the fans will revert to a lower speed.
Let's have a look, see if we can see that. Yes, we'll have a look to see if we can see that.
I can't see where it says, but
No.
obviously I know that once your lobby pressure gets too low, the fans will ramp down.
Right. Yeah.
Could it be footnote 3?
Yeah, it is. Line 3.
So it's a standard operation of fans by pressure differential switches, i.e. high and low speed based on open-closed doors.
Yes.
So where there's an X, are we to take that was the standard operation of the fan?
Where there's an X, it means...
Sorry, if we go along to the right,
Yeah.
it's been cut off on this screen view. If we go to the right of the bottom table, where you've got an X rather than 100%.
Yeah, that's for environmental mode.
Right.
So where on that very bottom row would be environmental mode activated, your main fans are off,
Yeah,
and your environmental fan is on.
I see.
And the reason that the roof fan is on in environmental mode, not the at the level 2, the environmental fan was a separate fan. On the roof fan, the same fan was
The same
utilised.
fan. Exactly.
for
Yes,
environmental.
that's our understanding. So at the
Yeah.
lower level, there were 2 fans and 2 different types of ductwork, and the system either had to opt for the environmental ductwork and the fan, or the smoke-controlled ductwork and the fan. Yes,
Yes.
that's at low level. Whereas at the top, it was the same fan
Same fan.
that was involved in both systems.
Yeah.
Yeah. Thank you. Now, you say in paragraph 22 of your first witness statement, I don't think we need to pull it up, that this document was used towards the end of the commissioning process. Can you explain why that was?
Because the initial days on site and the initial 2 or 3 visits in February were taken up purely by connecting, or not connecting, but checking all the connections on the system that had been installed by others, obviously.
Yeah.
That everything was wired to the correct connections on the boards, the correct panels, all the batteries, battery backup systems were connected up correctly.
Yeah.
So until the system was fully available for testing, that's the point where we'd have probably started using this.
Yeah.
And actually activating detectors on different levels
Yeah.
to make sure it did what it was supposed to do.
Yeah. So does that mean that you didn't actually use this chart until the April days?
Probably March.
March.
The March
Okay.
visit, yeah.
Yeah. Now, I just want to ask you some more detailed questions about this cause and effect chart. Do you agree that this cause and effect chart doesn't state what device causes the activation of the fire zone? You said that this shows you what happens when you're in the fire zone, as in the smoke control system's been activated.
It does. It tells you which smoke detector activates it on the extreme left-hand side.
Just show me where you're looking at. If we go to the extreme left-hand side.
Go to the extreme left-hand side.
Yeah.
And if you go up to the upper sheet, I think it says, well, it says it on both, basically, SDE01.
Yeah.
Then it says 26, then it says, well, 25, whatever.
And those are
else,
the smoke detectors in each of the lobbies, are they?
Yes.
Yes. But isn't it right that at Grenfell Tower, the fire zone, as you've called it, could be acted either by the smoke detector or by the fire service yellow override switch?
That could only be activated once the detectors The detector is the initial activation. So the smoke detector, on whichever level smoke is detected, activates the system. Once the system's activated, the key switch on the HMI at ground level in the entranceway can be turned to fireman's override mode.
So are you saying that you couldn't actually activate it straight off from the fireman's override mode?
No. None of those key switches are active until after a fire has been detected through a smoke detector and the fireman's override key switch, the master override at the HMI, is being switched to the on position.
I see. What about manually on the HMI panel? We know there's this HMI panel, human mechanical interface panel, in the lobby at the ground floor of Grenfell Tower. Couldn't you manually activate the fire zone from that panel?
Not until after a smoke detector had been activated.
I see.
And the key switch on that panel has been turned. Once the smoke detector is activated, it'll actually give you a visual message saying fireman's override available.
Yeah.
At which point you can turn that key, and then you've got the ability to activate the key switches on each level, one at a time if you wish to, or activate venting from a level on the actual screens that then come up, because those screens are not available to you until after a fire has been detected and then you've turned the key switch, and then the screen changes and gives you more options, including turning the system off.
Yeah. Do you agree that all three of those methods, though, should be tested as part of the commissioning process?
They were. We tested every detector on every level. We tested every key switch on every level, every pressure switch, etc. And then during the cause and effect testing, we would have activated a detector on one level and then moved it using key switches from level to level, and then moved it again using the HMI screens from level to level.
Yeah.
So we're proving that every smoke detector activates that level. We're also proving, or proved, that every key switch can move it from a different level, or if you wanted to use the HMI, you could vent from a different level using the HMI.
But can you explain why the cause and effect chart doesn't go to that extra level and explain that the system needs to be tested with all those other different types of activation as well?
I can't explain that. All I can say is it's because I know that that's how it works. And when I do a demonstration to the customer, I explain that to them.
Yes. Can you explain why the cause and effect chart doesn't include the functions and interactions of the HMI panel, so as to ensure that any actions taken by the fire brigade on the HMI panel in the event of a fire would provide the desired response?
I believe in the technical submission, the HMI panel description and how it functions is there, and it's also described during the demonstration to the fire service, which it was described by me to the fire service on the day in April when we did the demo.
Yeah, but can you explain why this cause and effect chart doesn't deal with the functions and interactions of the HMI panel?
It doesn't need to. All that needs to do is tell me what should happen when a detector on that floor is activated. The follow-up to that is the system design.
Yeah.
So that's me then saying, you know, I'll turn that key switch and activate fireman's. The screen will tell you fireman's override available.
Yeah. I'm going to suggest to you that there are some other absences from this chart. Do you agree that there's no reference in the chart to the effects of a mains power failure?
It's mentioned on item 7, backup fan, standby fan, and fault, and then operation at speed set on table. Again, those items are also covered in the tech sub. They're not, the cause and effect is purely to say if smoke's detected on level 13, damper 27 and 28, whatever, should open, you know what I mean?
I see.
And the rest of it is part of the system design and tech sub.
So you'd have to read the technical submission in combination with this in order to understand those extra features.
Initially. But
Yeah.
you've got to think on that, obviously, this is a guide for me during commissioning
Yeah.
to say, if that happens, this is what should happen.
Yeah,
The other parts of it are my knowledge.
yeah,
And obviously, I pass that knowledge on to the customer as best possible, you know, and I give them the option to ask questions, do
Yeah.
whatever they want.
yeah. What about the cause and effect chart dealing with a duty fan failure?
Well, as it says at the bottom, if the duty or if the main fan or standby fans fail, it'll switch over. And again, that's part of the commissioning sheet actually mentions it, failure in one part. We have to prove that if the power goes off, the backup power supplies will come on, which we did at both roof level and ground level, because they had two different sets of panels. So they had a primary and secondary supply at the roof and one on the ground level as well.
Yeah,
And we tested all of those with the system running.
yeah. Looking at the chart as well, do you agree that it doesn't state what dampers are intended to represent the north or the south dampers on a given floor? If you just look at the dampers.
No, but they are referenced on the 800. So I'm cross-referencing different drawings and different sheets constantly.
I see.
So I know that SD27, SD28, if you were to then go to floor 13, SD27 is probably south, SD28 is probably north, but if you look on the 800 drawing, it will state that.
Right. But why doesn't this cause and effect chart make that clear exactly which damper is the north and which is the south, so that you can be very sure when you go to it that you're checking the right one?
Because they both open at the same time, so it wouldn't really matter. The north and south shafts dampers operate simultaneously when a fire is detected on that particular level. And in reality, the only person that would want to know that initially would be me. And that's why I use the 800 drawing in conjunction with the cause and effect when I'm testing the cause and effect.
I see. Thank you. Now, looking at that chart about in relation to the fans in the bottom right-hand corner, we can see the columns relating to the fans, and we've already discussed the fact that they say whether the fans are at 100% speed or X, which is not operating.
Off.
Off.
It's off. Yeah.
Yeah. Now, wasn't the system designed to be able to control the speed of the fans so that they could operate at lower levels, not just 100% or nothing?
Yes.
Do you agree that there's no reference to a lower fan speed in the chart?
There's probably no reference because it itemises the pressure switch changeover on number 3. And that pressure switch changeover is based on whether the stair door to the lobby is open or closed. And then the speed at which the fan runs at the lower speed can vary floor to floor. So it's not a set, it's not the fan will run at 50% in low speed. Level 7 could be at 47, level 13 could be at 52. All of that's set up within the matrix on the HMI.
Yes, I appreciate it's set up on the HMI, but why don't we see any reflection of that in this cause and effect chart in terms of the potential for there to be different fan speeds at different phases?
Because until it's all set up at the end of the commissioning, nobody would know what those speeds were floor by floor at low speed. They were all very similar, but there were slight variations.
Yeah. On the 15th of April 2016, there were changes made to the programming of the system in environmental mode. Do you remember that?
Yes.
Do you agree that these ought to have been included in the cause and effect chart?
Potentially, yes, but again, they're all in the matrix. So if you look on the HMI into the matrix, all the speeds are there for you to look at. And they're not relevant to the fire brigade. They wouldn't need to see them. The only people that would need to see that matrix, and it's password protected for that reason, would be me at commissioning, and then any maintenance that were carried out on the system. A copy of that software with the full matrix is downloaded and stored back on the servers once commissioning's completed. So at any time later, if this information's lost, it can be reloaded
Right, I see.
and set to the commissioning values.
Just finally on this cause and effect chart, do you agree that it doesn't set out the 3 possible environmental mode scenarios for starting the system? So there's 3 different scenarios for how the smoke control might start. The system in environmental mode might be off and then the smoke control starts. The system might be on standby and then the smoke control system starts, or the environmental mode could be in full operation and then the smoke control starts. Can we agree that? Now,
It doesn't show it, but yes.
yes, why does this cause and effect chart not show those 3 different starting points? And wouldn't you need to test the smoke control system from each of those 3 different starting points, because different things would have to happen in the system under each scenario? Do you agree with that?
Yes, and I did.
Well, you say yes and I did, but I'm asking you why the cause and effect chart doesn't deal with that.
It's not normally what's put on the cause and effect. The cause and effect is normally what detector or what fire zone activates the system. And then all the bits after that are relevant to the tech sub and the HMI. It's not what we'd normally put on there because we don't want to overcomplicate it. I mean, that's a very complicated, very busy spreadsheet just to tell you what's going to happen if there's a fire on one floor. If we started adding everything else in, it'd be 5 pages long.
Yes.
And difficult to understand for somebody that don't understand.
Well, I understand that, but can we agree, and I think you yourself said this just a moment ago, that actually it is important for this chart to be entirely accurate, even if complicated, because the person maintaining the system would need to understand it so that they can do the right tests. Can we agree that?
Potentially, yes.
And can you explain why, therefore, an accurate cause and effect chart with the full types of data that we've just been talking about, including these different starting points, wasn't provided for the benefit of those maintaining the system?
As far as I'm aware, there was a separate sheet issued for how the environmental system worked, i.e. what floors vented at what point. So that, you know, and it's listed somewhere, definitely, I've seen it.
I see. So you'd have to look at a separate sheet for how the environmental system worked,
Yeah.
to look at the different modes of it, and then, but how would you know if you were maintaining this system that you ought to test it from the different modes of environmental operation?
Because again, it's in the tech sub that if as far as I'm aware it is, that if the environmental system's operating, then if there's a fire, the environmental system shuts down, it's locked out, and the system operates under fire mode as per cause and effect.
Yes.
And it is in the tech sub, I know I've read it.
Yeah.
And it describes which floors operate at the same time. The environmental mode is also timed. So you can set it to come on
Yes, I understand.
9 in the
Yeah.
morning till 10 at
Yeah.
night.
Would you accept that this cause and effect matrix was oversimplistic?
Because I understand how the system works, it provides me with all the relevant information I need to commission it.
But for somebody maintaining the system, do you think it provided them with everything that they needed to understand when they were testing the system subsequently?
Well, I would suggest that the company that were maintaining it was our company, because we've got all the software, we've got all the information.
Yes, but
I know the client's got a copy of it, but they've also got a copy of the tech sub. So all the relevant information regarding what happens if it's in fire mode and goes into environmental, which it can't. But if it's been in fire mode, you shut it down and reset it, and environmental mode is activated, it will go back into environmental mode.
yes, I understand that, and I understand that what I think you're saying is ideally you would have PSB maintaining the system so that that knowledge is carried forward. But I mean, how long was this system intended to last for? I mean, did you know that?
Well, there are certain rules and regulations, and
Approximately, I mean, how many years?
15 years minimum.
Yeah, and over that 15-year period, you could get a number of different people maintaining it, couldn't
Yes,
you?
yes.
So again, can we agree that in order for those maintaining it to understand all the tests that ought to be carried out to properly check the system, perhaps this chart ought to have been more developed.
It could be more developed, but then if the people maintaining it were efficient at doing what they're doing, it would be sufficient for them as well,
I see. Yeah.
combined with the tech sub and all the various drawings and documents.
Yeah. Now, can I just check, in paragraph 23 of your first witness statement, that you say you were given a copy of the PSB technical submission, that's what you're calling the tech sub, yes? Were you provided with revision 6, the final version, from 15th of March 2016, when you were commissioning the system?
As far as I'm aware, yes.
Yes, so you would have had that for your later visits, would you?
Yes.
Yeah.
Every time we do a visit, we check that we've got the latest revision of any drawings, so 800. I'm also emailed all the latest revisions of any software, which obviously I have to install. So, and I just basically check that each time I do a visit, I've got the latest revisions for any drawings.
Yes, thank you. Now, ahead of attending Grenfell Tower for the first time on the 3rd of February 2016, did you have any concerns arising from the quality of the documentation that you'd been given?
Oh, not really.
Did you feel that you had enough information about the system to test and commission it properly?
Yeah, yeah.
Yes, thank you. Mr. Chairman, I'm going to move on now to look at some
Would that
documents.
be a good point to have a
I think
break?
that would be a good moment for a break, yes.
All right, well, Mr. Partlow, we have a short break during the morning and the afternoon, and this is a good time at which to take it. So we'll stop now. We'll resume at 11:30, please. And I have to ask you not to talk to anyone about your evidence or anything relating to it
No problem.
while you're out of the room, all right?
Okay.
Thank you. Would you like to go to the usher then, please?
Thank you.
Thank you. 11:30, please. Thank you. Yes, would you ask Mr. Partlow to come back, please? Right, Mr. Partlow?
That's fine, thank you.
Carry on, thank you. Yes, Ms. Grange.
Yes, thank you. Now, I want to go at this point to the PSB Technical Submission Revision 6. This is the final version at PSB 50214. So we can see from the revision history that the final version was completed by David Harrison. He's the author, DH, on the 15th of March 2016. I think you just confirmed that you did have this prior to carrying out the visits towards the end of your commissioning process. Is that right?
I would have had a copy, yeah.
Yeah.
I wouldn't have had a paper copy. I would have had it on my laptop.
Electronic, yeah. And if we look at page 3 and go under 1.1.2 at the bottom of the page, under the heading Smoke Control System, we can see it says, the final smoke control system has been designed to provide the existing stairwell with protection from the ingress of smoke from a fire within a dwelling by means of a mechanical extract system. Do you see that there?
Yeah.
Now, just pausing there, according to your understanding as the commissioning engineer, to what extent was the system also intended to protect the lobby itself from smoke in the event of a fire on that floor?
The lobby systems are designed such that when the doors to the stair is closed, there's a pressure differential between the staircase, which is at sea level pressure or barometric pressure, depending where you are, and the lobby, which will be at a negative pressure, somewhere around about 25 to 35 pascals.
Yeah.
So even if that lobby fills with smoke, the fans are running, the dampers are open, there's a negative pressure, and the theory is that smoke can only flow from positive to negative. It can't flow the other way. So that should stop any smoke seeping out under the door into the stairwell.
Yes.
When the apartment or whatever that's on fire, when that door opens, obviously even more smoke's going to come into the lobby.
Yes.
But there's going to be some dilution because the fans are running.
Yes.
And you are pulling leakage air in under the doors, etc. But within a very short period of time, the stair door will be opened. At the point that stair door is opened, the differential in pressure is no longer available, so the fans will ramp up to full speed in about 10 or 15 seconds. From start to finish, they'll be at full speed.
Yeah.
At that point then, you're pulling cold, fresh air in from the stairs into the lobby. You're mixing and diluting any hot gases or smoke. And the apartment door, which was opened, should have closed behind the people escaping from that apartment that was on fire.
Yeah.
So the smoke from the apartment should be reduced greatly because now the door's closed.
Yeah.
The fans are now at full speed, so you're pulling a minimum of 2 metres a second velocity over that open door into that lobby. And the whole idea is that then dilutes the smoke, cools the lobby down to some extent. It's not going to take it back to outside air temperature by any means, but it should take it to a tenable condition whereby firefighters can then also come into that lobby and hopefully tattle that fire.
I see. So I think to answer my question in a brief way, your understanding was that the system was intended not only to protect the stair, but also to provide some protection to the lobby itself. Is that correct?
Yes.
Yeah. Now, if we read on within section 1.12, in the remainder of that first paragraph, it says the system, picking up in the second line, the system has been designed to provide an average open door velocity across an open lobby stairwell door of 2 metres per second. And then it said this velocity is in accordance with the recommendations for a Class B pressure differential system as defined in Code of Practice BSEN 12101 Part 6. That's the specification for pressure differential systems. Now, what was your understanding, in very brief terms, of what a Class B pressure differential system was when you commissioned this system?
That it is a protected lobby system that meets two standards: 2 metres a second when the doors open, velocity, and an opening door force of less than 100 newtons.
Yeah.
There are other bits and pieces, but as I said, this were a bit of an hybrid system, so it was trying to achieve the pressure differential system.
Yeah. Now, if we look at paragraph 114 of your first statement on page 19, here you explain the overall design basis for smoke control systems, which you say the design basis for smoke control systems is well known and long standing, namely a fire starting in a single location, being contained within a single compartment. However, some smoke will get into a common lobby from a fire in a flat, so the system was intended to ventilate the common lobby in order to control that smoke and so protect the common stairs. In doing so, some protection to that common lobby would also be provided. This was explained during the demonstration. Now, were you aware at the time you were commissioning the system that the lobbies at Grenfell Tower involved extended travel distances exceeding 7.5 metres for escape from the furthest flat to the stair door?
No, not really.
So that wasn't something you ever discussed with anybody?
That would have been something that would have been looked at design stage, and as far as I were concerned, it were a pressure differential system to protect the lobby and stairs.
Yeah. And we saw in the specification that the open door velocity when the stairwell door is opened was meant to be 2 metres per second. Did you understand that clearly at the time you were commissioning the system?
Yes.
And were you familiar with the requirements of the British standard that's mentioned there, 12101 Part 6? Were you familiar with that British standard?
Yes.
Had you read it at the time you commissioned the system?
A couple of 3 years before, probably.
Right.
Not on a daily basis, it's about 500 pages.
Yes, no, I appreciate it's a long standard. Did you ever come to look at it during the time you were commissioning the Grenfell system?
No.
No. So, to the extent you were aware of it, you were relying on your memory and what you'd read several years before. Is that fair?
That and the fact that I was under the impression that it was a pressure differential system, and we worked to the two standards: open door velocity and opening door force.
Yeah. Did you consider that that document was relevant to your commissioning work at Grenfell Tower?
It's relevant in respect of there's a set number of tests that have to be done.
Yes.
When you're commissioning, which all of those were done.
Yes. So you didn't feel the need while you were doing those tests or doing the test that you did, to go back and consult that British standard and check that you were doing the tests correctly? Did that occur to you?
No, because I'd done numerous lobby systems that were exactly the same as this, or as near as damn it the same, in numerous buildings. And when we did the first ones, obviously, yeah, we double check with systems, but again, it's something that had been done at design stage.
Yeah.
Rather than me.
And we've seen, what you've already mentioned, that one of the other performance criteria was that there needed to be a door opening force of not more than 100 newtons. Yes. And were you aware that that is one of the performance criteria in that British standard?
Yes.
Yeah. And if we go to section 3.3 of the technical submission again, so this is PSB 50214, page 18. Again, you've mentioned this before, but we can see that the system, if we pick it up under that section, that top section 3.3 mechanical control system, pick it up 4 lines down, we can see in the middle of that line it says the system is designed to maintain minus 25 pascals in the lobby with all doors closed and will maintain the fans at low speed setting. Once a door to the smoke affected lobby and only the smoke affected lobby, I think that should then read is opened, the pressure differential will be lost and the fans will automatically ramp up to full speed to extract air from the lobby at a rate which will provide an average force velocity of 2 metres per second across the open lobby stairwell door. So it's right, isn't it, that when the system's pressure sensors cause the fans to ramp up after the door opens, they ramp up to their full 100% high-speed setting, yes?
That's correct.
And if the door is then closed, the stair door's closed, and the pressure differential is restored, what speed would the fans then drop back to?
The predetermined speed that I'd set during commissioning.
And what predetermined speed did you set?
It did vary slightly from lobby to lobby because the size of the lobby, the leakage in the lobbies, so the door fits, etc., can vary. But they were all roughly they were all about the same. And if I said it were 50%, it's a guess because I can't remember. But they were all roughly the same. And that lower speed is the controlling factor in the door opening force. Because the faster the fans are running, the higher that force.
Yes.
So you have to, it's a very finely balanced match where you've got to make sure that the fans are running enough to maintain that negative pressure,
Yeah.
but not running too fast
Yeah.
to mean that the door opening force is too high.
Yeah. So does it mean that that fan speed is only something you can determine when you're doing the commissioning of the process and you're actually testing those two things?
Yes.
And the level at which you set those fans on the lower speed, that was entirely down to your judgment, was it, based on those two parameters?
Initial judgment, yeah. And some of them had to be lowered slightly, some had to be lifted slightly.
And when you say initial judgment, what do you mean by that?
From past experience, we usually set the pressure switches between about 20 and 25 pascals, but quite often have to turn it down a little bit. The pressure switch is a trigger point.
Yeah.
It's the point at which we trigger the fans to go to low speed. The next main factor is the speed at which the fans continue to run at that lower pressure to maintain that negative speed.
Yeah.
If your fans are too slow, then you won't hold the pressure and the fans will start speeding up, slowing down, speeding up, slowing down. So the leakage into the lobbies can affect that.
Yeah. And that's not something you ever discuss with a designer at PSB, that actually what you should be setting the fans at once you've come back from site?
No, that's done by experience.
Right. Now, let's just turn to the PSB commissioning method statement that we looked at earlier. PSB 50941. That's the method statement that we know you wrote under some time pressure, as you've explained. If we go to page 5 of it, we can see there's a section 4 in the middle of the page called System Description. And then if we can go over the page to page 6, if we look at the first 3 paragraphs of that, it says the main extract fan will start and begin to extract at a reduced load to ensure that as people leave the lobby into the stairwell, the pressure differential between the lobby and stairwell doesn't exceed 50 pascals. Then as people leave the lobby, the negative pressure equalises within the stairwell, air is drawn from the stairwell. The fan will vary in speed to maintain a pressure differential of approximately 45 pascals between the stairwell and the lobby. When the stairwell door is closed, last person escaped, there'll be no make-up air present. And as the differential pressure in the lobby increases, the fan will slow down, ensuring that the pressure differential between the stairway and the lobby doesn't exceed 50 pascals. Now, can we agree there's a difference, therefore, between this method statement and the PSB technical submission, because this method statement is specifying a bigger pressure differential than the 25 pascals in the PSB technical submission?
The 50 pascals is a figure that's derived from Smoke Control Association guidance and from the EN 12101 Part 6. It's a maximum. It's not an operating pressure. The operating pressure differential is going to be what is derived from the opening force on the door. So, again, there's two errors in that. The middle paragraph is an error. It says there'll be 45 pascals differential between the stairs and the lobby when the door's open. Well, there won't be a differential.
No.
When the door's open, it's the
Yeah.
same pressure. But the 50 pascals, because it's mentioned in other documents, it just gets referred to quite often.
Yes, I see. I understand entirely that 50 Pascal figure is in fact the figure that's suggested by the British Standard 12101 Part 6, and indeed, as you said, by other guidance documents. And I appreciate it says that it shouldn't exceed 50 pascals, but why doesn't it record in this method statement that the design criteria, the design performance criteria was set to achieve a pressure differential of 25 pascals? Can you explain that?
Because until I actually set the pressures and the door forces, it could be 50 pascals. It's unlikely, but it could be. The door force is derived from a simple formula, and it's pascals an area. So if a door is, for ease, 2 metres square, 2 metre square door area, and you apply 1 pascal to it, you'll get 2 newtons.
Yes.
So if you apply 50 pascals, you get 100 newtons.
Yeah.
If it's got a door opener on it that's 20 newtons, you've already failed. So it's never ever going to be 50, because 50 is a nominal figure that's in a document.
But would you ever go back after commissioning and explain what the pressure differential was in a document?
Yes, I would tell them what it was set at.
You tell them verbally?
Well, yeah.
Where would you actually record that in the documentation?
That had probably come out in the final revision of the tech sub.
Right.
And that's why there's a difference. Because the majority of those lobbies were set at about 25 pascals. Some were 22, some were 23, some were 25.
I see.
But the average switching point was 25.
Yes. You see, it's right, isn't it, that the technical submission, maybe you don't know this, but it was included in JS Wright's health and safety file for this job. So that would be the project's permanent record of the pressure difference. So are you saying that the reason why we see 25 in that version 6 is because that was the final pressure differential that was come up with?
It's what I set the pressure switches to, yes.
I see. So, and regardless of what's said in this method
Yes.
statement? Okay. Now, you said in paragraph 11 of your second statement that there were errors in the plural in the method statement. Can you help us? Were there any other significant errors in the method statement that you have spotted since?
Well, the second paragraph on that where I think it actually says air is drawn in from the stairwell and the difference would be 45 pascals. Well, there wouldn't be a difference, so that's just... It shouldn't have said that.
Yeah.
It's probably because, as I said, it was a modified version of a previous method statement.
Yeah.
And basically I'm going through it very quickly and trying to take out all the bits that are irrelevant and adding the correct bits back in.
Right. So are there any other significant errors that you spotted in the method statement?
Without reading it again now, I can't remember.
Okay.
I think possibly part of the description's not quite right.
Right. If we could go now to British Standard EN 12101 Part 6, we find this at RBK 3045054. There is that British Standard. And I think you agree from what you said earlier, but just to be clear, that even though the system wasn't designed to be in complete compliance with the systems identified in this British Standard, this does set out a methodology to test the criteria that you selected. Do you agree with that?
Yeah.
Yeah. Now, if we go to section 14 of this document first, on page 75, this section provides guidance on how to document the commissioning process. Now, and what the approving authority, that would be building control, should be provided with. Now, were you familiar with these requirements?
Yes, I've read them several times.
And we can see from the list, it's full calculations showing the design criteria, full specification details of the equipment used, that's in B. G is a complete maintenance schedule indicating the maintenance checks needed for each item of the equipment and frequency of the checks. And then H, on completion, the results of the tests carried out on the pressure differential system. Do you see that?
Yeah.
And then if we can go to another British standard, that's BS 7346 Part 8. This is at LAK 50242. This is a British standard called Components for Smoke Control Systems, and it's titled A Code of Practice for Planning, Design, Installation, Commissioning and Maintenance. And you can take it from me that the Smoke Control Association guide refers primarily to this British standard as the recognised code of practice for commissioning and acceptance testing of smoke control systems. Now, were you familiar with this British standard as well?
I have seen it, yes.
Had you read it before you attended Grenfell Tower in February 2016?
No, not before, but prior to that.
So you didn't read it immediately before. No. How long prior to it would you imagine you read it?
Possibly the last time that I looked at it for, just information could have been 6 months or even a year.
And if we go to look at clause 8.1 on page 30 of it, under commissioning, we can see in the notes at the top, it says the process of commissioning involves thorough testing of the installed smoke control equipment, including interactions with other systems. And then under that, the responsibility of the commissioning engineer is to verify that the system operates correctly in the manner designed and that the installation workmanship is of an adequate standard. It is therefore necessary for the commissioning engineer to be provided with the agreed specification for the system. Now, do you agree that this British standard applied regardless of the specific performance requirements for the Grenfell system?
Probably, yes.
So even if a system was not designed to meet the requirements of certain British standards, the components would still need to be tested and commissioned pursuant to this British standard?
Yeah.
Now, is it right, as we've just seen, were you aware that it sets out particular requirements for the person carrying out the commissioning? It says
Yes.
It's therefore necessary for the commissioning engineer to be provided with the agreed specification for the system. And then if we look at clause 8.1.1, it says below that the system should be commissioned by a competent person, see 8.1.2, who has access to the requirements of the designer, i.e. the system specification, and any other relevant documentation or drawings. And then below that, it says at 8.1.2, the person commissioning the smoke control system should possess at least a basic knowledge and understanding of the activities covered in Clause 5, Clause 6 and Clause 7. That's of this British standard. Now, if we can look at the contents page to see what 5, 6 and 7 deal with, that's at page 3 of this document. And if we go on and we can see it there, that section 5 deals with determining requirements for a smoke control system. Section 6 is about planning and design, and section 7 is about system installation. So would you agree that even if you were not involved in the design and the installation process, you needed to have at least a basic knowledge of those processes in order to commission the system?
Yes, and the information that I'm given prior to commissioning, such as all the drawings and documentation, panel drawings, control drawings, and the tech sub as it is at the time, is giving me that information.
Yes, I appreciate you've got that information on this specific system, but in general terms, how familiar were you with determining the requirements for a smoke control system, with planning and designing a smoke control system, and installing a smoke control system?
Well, the planning and design of it would have been done by the designers. The installation, if our own installers were installing it, then we'd have been controlling the install from day one. The project manager would have been checking that the install were carried out correctly. In this case, it was done by others. But it was checked. It was checked by more than me. Other
I see.
people went to site and checked it.
Yeah.
So the installation was checked. As far as I'm aware, it was all okay.
Yeah. And as far as you're concerned, you were a competent person under this guidance to be commissioning the system.
I would hope so.
Yeah. If we go to clause 8.1.3 on page 30 of this document, this then lists particular requirements for inspection and testing. So it says at commissioning, the entire system should be inspected and tested to ensure that it operates satisfactorily, and that in particular, and you can see at B, the agreed cause and effect requirements are correctly implemented and the system is tested and responds to any planned method of initiation. I'm not going to read all of them out, but were you familiar with these requirements?
Yes, they're amongst the ones that are also required in 12101 Part 6.
Yes, I see. And over on page 31, the final requirement listed is for a commissioning system signed by a competent person. That's at M at the top of that page. Now, in your case, do you consider that would be met by you providing such a certificate?
Well, we did issue a commissioning certificate to say that all the various component parts had been tested
Yes.
according to the two standards that you've mentioned. So, yes.
Yes. And then if we go to clause 8.1.3, sorry, we've just got that. After M, go back onto page 31. Yes, after M, we can see it says all results obtained during the commissioning process should be clearly recorded. Again, did you understand that?
I understand it, but the results I recorded were the relevant results to door velocities, door force, and whether or not component parts operated correctly, i.e. dampers opening and closing, etc.
Yes.
So all the items listed on the commissioning sheet is what I believe are relevant to the commissioning process.
I see. But does that answer mean that there were some results that you took during the commissioning process that didn't then make its way into recorded documentation?
Not as far as I'm aware. All the results that I recorded were all recorded and issued.
Yes. Below that, under documentation, it then says, on completion of the certificate, the following documentation should be provided to the relevant responsible person. And A is the certificates for design, installation and commissioning. And then at B, we can see an adequate operation and maintenance manual for the system, providing information specific to the system in question, including a list of equipment provided and its configuration, routine weekly and monthly testing of the system by the user, information about service and maintenance of the system, etc. C is as-fitted drawings, indicating but not limited to the positions of all control, indicating power and supply equipment, positions of all equipment that might require routine attention or replacement, the types, sizes and actual routes of the cables. And then D is a logbook at the bottom of the page, and E is a record of any agreed deviations from the original design specification. Now, were you familiar with those requirements?
Yes, and as far as I'm aware, they were all acted upon.
Okay. Now, let's go to the Smoke Control Association guide. This is the 2015 version at RBK 402932. Now, just before we come on to the detail of this guide, were you aware that on the 4th of May 2016, the RBKC Building Control Officer, Mr. Hanson, had sent PSB this guidance, this 2015 SCA guidance, and asked for the building control witnessing of the system to be done in accordance with Section 9 of this document? Were you ever made aware of that?
At the time it was sent, probably no. Since then I have seen the document.
Yes. In your experience, was it common for building control to request compliance with the SCA guidance during commissioning activity?
Not normally, no.
No, that wouldn't normally be requested.
Well, we provide them with a commissioning certificate, a completion certificate, and usually building control would have been there at witnessing,
Yes.
which I understood at the time that they were. It was only after the event that I found out that weren't.
Right, yes, we'll come on to that. Now, section 9 of this SCA guidance at page 59, it covers commissioning and acceptance testing and has a list of actions in addition to those required by BSEN 12101. Did you ever, perhaps if we just look up this at the page before. Yes, so in this section of the SCA guide, this is section 9, what it's doing is for different types of systems, it's setting out what checks ought to be carried out as part of commissioning and acceptance testing. And for pressure differential systems, if we go back a page, this is the list that the SCA guide provides. And we can see that it includes operating each motorised damper, this is the first bullet point, by activation of the designed manual or automatic device. Measuring fan performance, we can then says check that the fans operate at the same times as the opening of the dampers, measure its performance and check against the design value, and then check various changeovers relating to the standby fan and the secondary power supply, etc. So we can see that list. And we can see the 6th bullet point is checking the maximum forces required to open escape doors while the system is operating in means of escape mode and record results. The recorded force must not exceed 100 newtons. So can we agree that to ensure compliance with this SCA guidance, one would need to carry out these tests on top of any required by the British standards themselves?
All those tests were carried out.
Okay. So you did appreciate that at the time of the Grenfell commissioning process?
Yes.
Did you actually look at the SCA guide while you were doing the commissioning?
Not that week, but again, it's a guide that I refer back to whenever I need to, and it probably it's been updated several times. But you know, the initial ones I think were 2011, then 14, then 15, whatever. Whenever there's an update comes out, we get a copy, and I'll read through it to see what's changed.
Yeah. Now, before we explore the particular measurements that you took and the particular testing you did, just in terms of the general process you followed and the key documents you produced as a result of the commissioning, I've got some questions on that. Now, paragraph 14 of your first statement, we don't need to turn it up, you explain that commissioning a smoke control system in a high-rise building is a 2-person job. Is that correct?
Generally, it needs 2 people.
Yeah.
Yeah.
With one person checking the physical system is working on each floor while the other checks the HMI panel on the ground floor. Is that correct?
It's not just that. It's 2 persons are required to carry out various checks.
I see.
But one of the ones which I highlight is the fact that when you are checking that dampers are operating, whether it's from a smoke detector or from the HMI screen, somebody's got to be on the actual floor.
Yes.
To make sure it has opened and closed.
Yes.
They have.
And is it right that at Grenfell Tower you worked with the assistance of someone called Gary Doyle, who was a self-employed electrician who PSB had used for a number of years?
That's correct.
And to what extent was Mr. Doyle actually involved in taking commissioning measurements himself?
He didn't really take any of the measurements. He assisted me in taking them.
Yeah. And I think, as you've already explained this morning, you said in your statement that initially, or in your first statement, initially due to the ongoing building work on the lower levels, you were only able to test the system on levels 4 to 23. And you said you did this in the first 2 visits, and that in later visits you completed the commissioning of the whole system. And is it correct that you therefore produced something called an above-ground commissioning report on the 26th of February 2016 for floors 4 to 23?
Yes, I did.
And you then produced the final commissioning report on the 28th of April 2016, is that correct?
It is, yes.
And if we could go to paragraph 8 of your second statement on page 2. and we looked at this earlier, you said that that interim report, the above ground commissioning report, was not intended to be used as evidence that the system was fully or partially commissioned. It just demonstrated that certain elements of the system had been tested and were working, rather than being able to say they were commissioned. Now, was it usual to test a system in parts like that?
No.
Were you happy to be completing a partial report, or did you have concerns about doing it in that way?
Because of the way the building changes were progressing, it made it possible from level 4 to 23 to at least prove that switches were working, dampers were working, smoke detectors were working. There's also a lot of work involved in powering the system up, because it's all electronic cards, etc., outstations. You can't just switch the power on. You've got to do a lot of dead testing, it's called, basically, where you're testing every single wire to make sure it leaves the right place and arrives at the right place, so that when you do start applying power onto all the various parts of the system, basically you don't blow it up.
Yeah.
So it's a bit of it's a long drawn out procedure, but by being able to go on site at the beginning of Feb, or whenever it was, and looking at the floors that were complete electrically and mechanically,
Yes.
we were able to prove that things worked.
Yeah. Yeah.
Now that's only operational. It's not cause and effect, it's not volumes, it's just purely operational.
Yeah. Now, I think you have explained earlier, and we've seen it in some emails, but I don't think we need to go to them, in fact, that you were asked in December 2015 whether there was a way of getting the system up and running before Christmas. Do you remember that?
I do, yeah.
And your response was, it's not possible to operate any part of the system without applying the power, and if this is done without fully testing the system, then damage to the cards is possible. Do you remember that?
Yeah.
Now, do you remember, was the TMO or Ryden pressing PSB to make the system available for use prior to the full commissioning being completed?
Oh, yeah, probably.
When you say, yeah, probably,
Well,
do you
yeah,
actually recall that that's what they were doing?
Yeah, because even when I made the first visits in February, they wanted the system to be like a working system with only, with 3 or 4 levels not even complete. And it just don't work.
Yeah.
You can't do that.
No. And did you ever take any shortcuts as a result of the pressure that was being applied?
No.
No.
No, they can apply as much pressure as they like. It don't change what I do.
Yeah. Now, at paragraph 16 of your first statement on page 4, you say, I cannot recall exactly what I did during each visit to Grenfell Tower, but I used the same essential step-by-step process I always use when commissioning a smoke control system. Now, was that step-by-step process one that you'd actually drawn from guidance documents, or was that just based on your own experience?
It was a combination of guidance documentation, training from the company's previous and present smoke control specialists who do understand this guidance fully, every word of it, and combining that with my electrical and mechanical background to ensure that we tested all the component parts of the system safely and correctly.
Yes. Now, did you keep a day book or other written notes yourself when you were doing the testing?
Most of my notes and jottings down are usually on back of drawings, which, once it's done, they've got footprints on them, coffee stains and everything, but I don't need to, because until I actually take all the final readings. The 800 drawing, for example, when you're commissioning the system and you're testing each piece, once I've tested a damper and proved that it fully opens, fully closes, when you tell it to, I tick it. So I know I've tested that one damper.
Yeah.
And that applies to every part on every level throughout that building. And until every little one has got a ticket side of it, that's when I know I've actually completed everything.
Yeah. And if we can look at paragraph 21 of your second statement on page 4. You say, we'll come back to the door readings in due course, which you're dealing with in the first sentence. You say that you didn't retain the 10 to 12 individual readings for each door, as the average figure was the only one that had to be formally recorded for commissioning purposes. Then you say, I normally dispose of my working notes a short time after a job has finished. After my work at Grenfell Tower had finished, but before the fire occurred, I disposed of my working notes, which contained the individual readings for each floor.
Each door.
I beg your pardon. Each door, thank you. So just to be clear, were all your working notes disposed of in that way? They're
not.
Nothing retained?
They're not working notes in the sense that I have a diary or a day-to-day notebook. As I said, I use the actual drawings as a tick sheet, and then when I'm taking readings, I might write things down on level 11. The readings that we take on a door, the vein anemometer that we used for that is such that you can select a test, so we'll call it test 1, and then you move across the door several times and down the door, and each time when it settles you press a button.
Yeah.
And then you go to what's called, the next step is data, and it'll give you the lowest reading, the highest reading, and the average.
Yes.
Within its software, it disregards the lowest and highest.
I see. Yes.
And calculates the average, and that's the figure that I would have written down.
Yes, thank you. And I'm going to come back to each of the individual tests in a moment, so you will get the chance to explain for each one what you actually recorded and then what gets written down. Was it PSB's general policy to dispose of notes taken during commissioning? Was that your understanding of?
It's not a case of disposing of notes. It's a case of once the boot of my car got full, I had to take some paperwork out. Any drawings or relevant documents that needed registering on the server would have been emailed in, and then any changes to drawings, we redline them so that the as-built drawings that are issued would have had any updated bits on, such as a connection change or anything like that in an outstation.
Yeah.
Because this job went how it did over a lot of days, all those were done as and when.
Yes.
So, I tell them, you need to update this outstation because now on X3 and X4 you've got this. That were done. Those sheets would have then been sent back to me for printing off and put in the outstation.
Yeah.
So everything was kept up to date as progress went along.
Yes, I understand. Now, in your first statement, if we just look at it at paragraph 139 at page 23, you describe there the reports that you produced, and you talk about the above-ground commissioning report. And then we know there was a final commissioning report. Sorry, this is paragraph 140 is actually the paragraph. You say you completed 2 commissioning reports, the above-ground commissioning report February 16, the above-ground commissioning report April 2016, and then we know you produced the completion certificate on the 3rd of May 2016. And it's right, isn't it, that PSB also provided an operation and maintenance manual and a testing and maintenance schedule, is that correct?
They normally do, yes.
Yeah. Now, if we go to page 4 of the commissioning report, this is the 28th of April 2016 commissioning report at PSB 50224. Actually, let's just bring up that document, PSB 50224. This is the PSB above ground commissioning report from the 28th of April 2016, and we can see your name there. Now, if we look at page 4 of this, we see a section for fire service override switch. Do you see that there?
Yep.
And the report underneath that title, fire service override, it says check functionality of the fire service override switch. And in the box saying installed, it says yes, and tested, it says yes. Now, if we look at paragraph 38 of your first statement on page 7, you say here, I operated the fireman's override switch using the key to check that it would work mechanically. I also checked to make sure it was connected to the correct connector on the outstation. So you say that you're telling us there what you actually did. Did you do that for all the firefighters' override switches in the building?
Yes. That reference on that sheet to the fireman's override switch is the master override on the HMI. This reference is to the fire overrides on each level.
I see. So is it somewhere recorded in the commissioning report what the test of each separate fireman's override switch on each level,
Yes.
that they were each tested?
Yes.
I see, thank you. And if we go back to page 3 of the commissioning report, this is at PSB 50224, page 3. At the bottom of that page, in the larger table at the bottom, we can see that for pressure switches, that this is three items down. It says pressure switch PS01 to PS24. Is it right that the only information in the commissioning report is that in respect of the pressure switches, we've got auto
Operate.
okay, so that it operates okay,
Yeah.
and then damage okay, and then pass yes. Do you see that there?
Yes.
Now, if we look at paragraph 39 of your witness statement on page 8, you tell us in your statement, you said, I checked that the pressure switch was mounted in the correct area in the staircase and lobby and that it activated if the air resistance changed. I did this by sucking air through a piece of plastic pipe which I attached to the static tube which formed part of the pressure switch. I checked to make sure it was connected to the connector on the outstation. I also set the pressure switch to 25 PA at this stage. Now, do you accept that you're giving us a lot more information in your witness statement than you gave in the commissioning report?
Well, in the commissioning report, it says pressure switches 1 to 24, if that's what it was. And then it says operate, okay. In other words, when the pressure changed, did the switch operate? The answer is okay to all those 24 switches.
Right.
And there was no damage to any of the pipework or the switches or the boxes that they're held in. And that it passed. And that reference is to PS01 to PS24. It's a bit, I could have written PS01, next line, PS02, next line. But again, this were a document that they wanted the following day, basically.
I see. Does that mean that you provided less detail in the report than you normally would in a commissioning report?
No, I provided about the same details.
Yeah.
Probably less detail in respect of itemising each item.
Yes.
So a line per item. I clustered them together, said pressure switches 1 to 24.
Yes.
In one column.
Yeah, I appreciate one possibility you could split those all out, but also in paragraph 39, is it fair to say that you're explaining that you've done different checks of the pressure switches, and that's not explained in your commissioning report? So you've said you've checked that it was mounted in the correct area, that it activated if the air resistance changed, and you've given the methodology by which you've done that. You've checked to make sure it was connected to the correct connector on the outstation, and you've set the pressure switch. So there's a number of steps. Why aren't those steps all recorded in your commissioning report?
It's just to the best of my knowledge, that commissioning report is an outline report of what we've tested, and that we've tested it and it functioned correctly. It's not a detailed check. You know what I mean? So that's telling you what I did on each pressure switch. The report's just saying that each pressure switch was tested.
Yes.
And the test is all of that, basically, along with other things such as like when the fans are running and the door opens, does the pressure switch activate and the fans speed up? When the door closes, does it slow down, etc.?
Yes. It's just that wouldn't it have been helpful for those people looking at your commissioning report in the future to know precisely what type of checks you'd done, for example here for the pressure switches?
Potentially, yes, but as I say, for purposes of me commissioning the installation, I know what checks have got to be done and I carry them out.
Yes.
And I
okay.
did carry them out.
Now let's look at the particular measurements you took of the system in more detail. And you've told us that you were familiar with BSEN 12101 Part 6, which provides guidance on acceptance testing and various acceptance testing stages, yes? You were familiar with that?
Yeah.
And that's in section 12 of that British Standard. If we could bring that up, RBK 3045054 at page 72. So here we've got, in this British Standard, acceptance testing for pressure differential systems. And it's right, isn't it, that in section 12, these acceptance tests are different stages that must be undertaken when commissioning a smoke control system of this nature.
Yeah.
And if we look at section 12, each stage has instructions on how to do the test and the criteria that the system must meet. Yes?
Mm-hmm.
Now, let's start with the first acceptance test. That's a pressure differential test. This is, you can see that there at 12.2.1. Now, looking at the test, it says that the first acceptance test should be carried out to establish pressure differential due to wind and stack effect, with pressure differential fans switched off. So this appears to be, can we agree, like a baseline check to see what the pressure differential is between the different areas? So here it would be stair and lobby, yes? So it says, initiate the pressure differential system operation, allow fans to operate for at least 10 minutes to establish steady air temperatures, switch off the pressure differential system fans, leaving all other components in their operation mode, measure the pressure differential between the pressurised space and the relevant accommodation, measure the pressure differential between the staircase that's to be pressurised and the relevant accommodation on at least 2 storeys. These readings should be taken using a calibrated manometer with the appropriate tube connectors. And then it says the pressure differential measured relative to the first acceptance test shall comply with the minimum values indicated in figures 2, 3, 4, 5, 6 and 7. Now, was this a process that you followed? Did
Yes.
you run the system's fans for 10 minutes and then take those test measurements with the fans on?
Probably on the second visit in February, and we probably did it on level 4, round about 10, 16, and the topmost level. We did exactly that, and I had a DPM meter, which is a differential pressure meter, and basically checked the difference between the lobby pressure and the stairwell pressure. And with the fans off, there wasn't one.
Right.
In fact, when we tried the airflows, on the lower floors we got a slight airflow on the north shaft, nothing on the south. And on the upper floors we got a reversed airflow.
Yes. And just to be clear, this talks about the relevant accommodation as being the one of the test areas. In Grenfell, that would have been the lobby, wouldn't it, that you were comparing?
That's what I was comparing, the lobby, not the actual accommodation off the lobby, because obviously
it's a
there were
difference.
people living in them.
Yeah. And if we look at clause 12.2, the note. So under 12.2 acceptance test requirements at the top of that page, we can see the note says, in buildings higher than 8 stories, the tests specified in 12.2.1 and 12.2.2 should be carried out in groups of 8 floors. Now, at Grenfell Tower, there were 24 floors. Do you agree that this standard therefore required this procedure to be carried out at least 3 times with floors assessed in groups of 8?
We did do, yes.
Pardon?
We did.
You did that?
Yeah. I did it on 4, something like about 11, 16, and then the top floor, 23. And then afterwards, we also did a test on ground for the same test, basically. But we never tested between the lobbies and the accommodation,
No.
the flats, because
I understand
obviously...
So you did this test of putting the fans on, turning them off and seeing what the pressure differential was.
Several times.
On a selection of floors.
Yeah, several times.
Yes. Do you agree that there's no record anywhere within the commissioning documents of any pressure testing?
No, there isn't.
Why not?
When we actually ran the system and tested the door opening force, Max Fordham's consultant asked us to measure the differential between the stairs and the lobby. And we got, on average, we did it on several floors, this is with the system running, and we got between 30 and 35 pascals.
Okay. But can you explain why there's no record in the commissioning documents of any pressure testing having been carried out?
Because the only two tests that we recorded was the door opening force and the open door velocity. We still took the readings to see what we were getting, because that's your baseline. So like I do a door opening force with no fans on to see what we got with just the door closer.
But I think the suggestion may be, Mr. Partlow, that you ought to have recorded
Yes,
other readings.
I fully agree. Yes. Right. And I'm sure in future, or once these things have been done, I'm sure that will happen.
Yes, thank you. That's helpful. And if we look at paragraph 24 of your second statement, page 4, I think you're just describing, what you're describing here is what you were just describing.
Yeah. We did that on every level.
Yeah, so at 23, I think, is the paragraph. You say, prior to the final commissioning in April 2016, I did this by setting the pressure switches to the required level on each floor and judging the door opening force based on my experience, etc. And you tell us, sorry, I think that's a wrong reference, but somewhere in your statement you do say that you, prior to the final commissioning, you checked the pressure differential in the common lobby door using a pressure differential monitor.
The next part down, 24.
Yes, I see. Now, was the system running when you took those readings?
On those readings, yes.
It was?
Yes.
So it wasn't following the British Standard method?
Well, it's both, because you've got to have a differential pressure within the lobby to the stairs.
Yes.
And it's got to be an acceptable level, but that level is derived by the door opening force. But the actual levels we were getting varied between about 28 and 33 pascals differential pressure.
Yes.
And the average door opener, if you're interested, were about 12 newtons. It varied. So that's what controlled what pressure we could apply.
Yes. Now, if we look at paragraph 24 of your first witness statement on page 5, here we can see that when you tell us that when you commission a system that you take with you a multimeter for measuring basic electrical tests, voltage, etc., a calibrated anemometer used for measuring airflow speed, basic electrical tools, a set of two-way radios. Do you take a calibrated device for taking pressure differential readings with you?
Not on the first visits, no, because we wouldn't have anything set up to measure at that point. Probably from the second visit, and the second and maybe even the final visit. Well, the final visit definitely had the DPM with me.
I see. So, because here, this paragraph seems to be suggesting that it's summarising all the equipment you take when you're commissioning.
That's probably 30% of what I take with me.
I see. Okay.
I can only carry so much on tube.
Yeah. Now, the second acceptance test is called the net pressure differential test. We can see that at clause 12.2.2 at page 72 of the British Standard. If we can go back to that, RBK 3045054. So within 15 minutes, having completed the requirements of 12.2.1, the first pressure differential test, the second acceptance test shall be to measure the net pressure differential across each door, separating a pressurised and an unpressurised space to the relevant accommodation on all floors with the pressure differential system running. And then over the page, the change in measurement between the first and second pressure readings shall be compared with the performance requirements specified for the design pressure differences. Do you see that there?
I do, yeah.
Now, were you familiar with that test?
I have read it previously, and we did did the first and second parts, but not within 15 minutes of each other.
That was my next question. So this standard requires you to do it within 15 minutes of the first test. You're saying that you didn't do that. You did them on separate occasions. Is that correct?
We did them on more than one occasion, but yes.
Now, can we agree that it requires measuring the net pressure differential across each door between a pressurised and an unpressurised space to the relevant accommodation on all floor levels with the pressure differential system running? I think if we go back a page and look at the first part of what it said. Across each door, separating a pressurised and unpressurised space on all floor levels with the pressure differential system running. Now, I think you've explained that you just did it on a sample number of floors. Is that correct?
The pressure differential, the initial test with the fans off, dampers open, we did on at least 4 levels, starting at lower level, a quarter at way up, 3/4 at way up and top. The second acceptance test, which admittedly we didn't do after 15 minutes because we couldn't at the time because not all floors were available.
Yes.
But we did do the pressure differential across every door on every floor
Right.
with the fans running.
But we don't see any results of that set out in the commissioning documents, do we?
No.
No.
We did record the pressure differential during the run testing because that was Max Fordham's request to have a copy of those numbers, which we did supply. Or JS Wrights took the readings down that I gave. JS Wrights also, with the spring test, took the door force readings and wrote them down.
Yes, I'm coming to the door force readings in a moment, but do you accept that if you'd been following this guidance, we ought to have seen all the results of that pressure differential testing on each floor, the net pressure differential test that you said you did, in the commissioning report?
Yes, I accept that.
Yeah. Yes. Now, the third acceptance test, if we look at page 73 of the British Standard, so the next page, is called the air velocity test. It says the third acceptance test shall measure the air velocity through an open door separating a pressurised and an unpressurised space and shall comply with the requirements in clause 4 for the appropriate class of system. The test shall be carried out as follows, and then it sets out a procedure. Now, it's right, isn't it, that this testing is against the open door criteria in clause 4.3.1 of the standard. We can see that from clause 12.2.3.3 in that section. So 12.2.3.3, it says the measurement of flow velocity through the relevant doors shall be taken with all other doors open or closed in accordance with the appropriate class of system described in clause 4. The doorways shall be clear of instructions, and then you're to see figures 2, 3, 4, 5, 6 and 7 regarding the relevant door. Now, did you understand that that door reading needed to be taken with a combination of other doors open?
On the type of system that's installed, the only door that you need to have open and that would have any effect on the system is the door on the fire floor. Opening a door on any other level would have no effect on the system at all. So if you opened a door on the level above and a level below, because you're not extracting air from those areas, you're not changing the pressure. So the only level that's got a change in pressure or volume, velocity, is the one where the dampers are open and the fans are sucking air out from.
Yes, I see. But let's look at the doors that have to be open. We find that on page 20 in section 4 of this guidance. This under 4.3.2.2, we can see it says there the air supply shall be sufficient to maintain a minimum flow of 2 metres per second through the open door between the lobby and the accommodation at the fire-affected storey, with all of the following doors open between. And A, the stair and the lobby on the fire-affected storey, the stair and the lobby on an adjacent storey, the firefighting lift shaft and the lobby on the adjacent storey, the stair and the external air at the fire service access level, and the air release path on the fire floor is open. Now, I appreciate the point you're making, I think, is that the design was only intended to ever have one door open. That's the stair door, yes?
Part of that you're reading there is from a pressurised system.
Well, this is for a Class B pressure differential system, and we understand the airflow rate of 2 metres per second to come from this part of this British standard. When he gave evidence on last week to the inquiry, Mr. Hanson, the building control officer, said that his expectation was that PSB would be testing as part of the commissioning process with other doors open or closed in accordance with this British standard. He said this, he said the technical submittal proposed the 2 metres a second airflow test in accordance with this standard. So my expectation is that it would be tested in accordance with this test procedure and opening and closing the relevant doors to the Class B system. So that's clearly stated in the technical submittal. Now, I think what you're telling us is that when you were testing the airflow through the open door, you didn't do it with other open doors. That wasn't ever part of your commissioning process. Is that right?
We didn't, no, but opening the door below or above the storey where the fire is would not change the velocity on the door that was open, because you haven't got any fans acting on that level. And this is talking, what you're talking there is looking at differential pressures. So if you did open doors on other levels, you wouldn't create a differential pressure. And even if you opened the doors on the level that was supposedly on fire, there wouldn't be a differential pressure.
I
If you
understand.
just help my understanding.
Yes.
Are you putting it to Mr. Partlow that the effect of opening doors on the doors between the stairs and the lobby, one floor above and one floor below, would in fact affect the velocities through the fire floor door?
Well, I'm certainly putting it to him that under
If
this,
so, why? Because I don't understand.
if this standard, it should have been checked. That's what I'm putting to him.
Well, I know that, and his answer is it wouldn't have made any difference. And I'm just wondering whether you're inviting him to rethink that or not to accept that. And if so, I would like to understand why, because at the moment I can't see it either.
I appreciate that, and it may be that we need to ask that question of our expert in due course. I can't put a positive case that opening particular doors, certainly on the fire floor, opening the flat door and the stair door, my understanding is that potentially would create a difference. Mm-hmm. You accept that, yes?
Oh yeah, definitely. But
yes.
We couldn't open accommodation doors, if you want to call them that, to the flats, because you can't knock on somebody's door and say, can I open your door, please? Although it did happen whilst we were testing fans. Somebody would come out to find out what was all the noise were about, and all it would do is basically suck air out of that room.
Yes.
All right, I'm sorry.
For a few seconds.
I just didn't quite understand what
no,
you were
I think the
putting
more
to the
nuanced position about, say, a stair door above or below, and whether that could affect the pressure across that, the airflow across that door. I'm not going to answer that question today. But I do understand that it is accepted that once a flat door is open, as well as the stair door, then potentially that does affect whether you can maintain 2 metres per second, yes?
It would do.
Yes.
But it would, unless there was broken windows or something like that, you would pull some air from the flat, and the air will take the easiest path, which should be through the stair.
Yes, thank you. But just to be absolutely clear, your commissioning process checked the air velocity of that stair door when just the stair door was open and all other doors were closed?
Yes.
Yes, thank you. were you aware that the test, if we go back to page 73, this door velocity test, airflow test, if you look at 12.2.3.4, do you see there it says that you have to take at least 8 measurements uniformly distributed over the doorway to establish an accurate air velocity? Calculate the mean of these measurements, or alternatively move an appropriate measuring device steadily over the cross-section of the open door and record the average air velocity. Now,
Yes,
did you do that?
Yes. As I said earlier, the anemometer we use is a vane anemometer. You've got 2 or 3 buttons on the front of it. You can press one of the buttons, scroll down, and it says select test. So you'll select test and it'll say test 1. You scroll down again, there's another take measurement, so you select it. You put the vane anemometer in front of the door, you press the button, and you put a predetermined time in, say 3 seconds. And after 3 seconds, it'll record a static number. It's not flashing. That static number is the average velocity during that 3 seconds. You then move it across and press it again, and it'll do the same again.
Yes.
And you do it again. And we probably do that on an open door, 2 metres high, 12 times.
Yes.
Because we'll do it there, and at bottom.
Yes.
You then end test, and when you go in then, it'll say data. And it'll give you the highest velocity, and it'll give you the lowest.
Yes.
And it'll give you the average.
Yes.
And that's from 12 readings.
Yes.
So it discards the highest and the lowest.
And the lowest.
And takes the average of the remaining 10.
Yeah.
And it gives you that figure, and that's the figure that I wrote down.
I see. And so, it's that average that we see recorded in the commissioning report.
Yes, that's the average based on the anemometer itself.
Yes, that's helpful. Can I just look at what you said in your witness statements about this? If we could go to paragraph 106 of your first statement at page 18. You say here in this part of your statement, I took airflow readings using an anemometer. Is that how you say it? Anemometer.
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 Anemometer, whatever.
From the top, middle and bottom of each door on each level when the system was operating in smoke control mode. The readings I recorded were an average figure of the readings taken from around the door. Now, do you see that written like that? It sounds like you've just taken 3 readings, top, middle, bottom.
Yeah, I know it's not a very accurate statement, but I can assure you we took the minimum required. We probably took more. We take 3 readings, left hand, centre and right hand side at door, in at least 3 positions. So if we did top, middle and bottom, that'd be 9. But we'd probably do more than that. We'd split it into 4 quadrants.
I see. And if we look at paragraphs 20 and 21 of your second witness statement on page 4, you say there, the open airflow velocity readings in smoke control mode were taken using an anemometer by taking a number of airflow readings, normally between 10 and 12 from different locations across and up and down the common lobby door on each floor. I made a note of the readings and used them to calculate the average reading for each door. I recorded the average readings in column 2. So I think that is more consistent with what you're saying happened. Is that right?
Yeah, we had probably 3 different types of anemometer, 2 of which did self-calculations, so they were the easy ones, 1 which you had to actually write them all down. And we used to have a grid pattern that we use for ventilators, for doors, etc. And that pattern is 9 minimum, and that's what we used to use. Even after this statement, when I looked back at because I found a document with the anemometer certification for the calibration, and the one that I used is the one that does the automatic summation of the readings.
Yes, I understand. And you say, I did not retain the 10 to 12 individual readings for each door, as the average figure was the only one that had to be formally recorded for commissioning purposes. Where do you get that from, that you only actually have to record the average? Why didn't you formally record the different readings you took and then explain that it was an average, or Why isn't that set
Well,
out?
the readings were actually within the software of the anemometer.
So you couldn't do that?
And unfortunately, the laptop I was using at that time, we had some software where you could download that onto an Excel spreadsheet, and it would have actually have downloaded all those readings. The laptop I had at the time wouldn't operate that software.
Right.
Otherwise, I'd have saved that software. I'd have saved all those tests.
Yes.
And it would just spin another spreadsheet with a load of readings on.
Yes, I understand that. So was that the normal practice, that the anemometer would download automatically, produce these readings in a spreadsheet, and that would go in the commissioning report? Was that the
Yes,
normal practice?
With that particular anemometer, yes, we could do that.
Yeah.
And download that spreadsheet.
And was that your normal commissioning practice?
When we could use that software, yes.
Yes.
Unfortunately, at Grenfell, the software wouldn't work on the laptop I had, so I couldn't download it.
Yes, I understand. Now, just to look at what we get recorded in the above ground commissioning report, if we could go back to that PSB 401152 at page 8. This sheet and then the sheet below on the next page, page 9, is the two sheets of measurements of readings that we get included in this commissioning report, yes?
Yeah.
And I think what you're saying on this page 9 is that for each floor level, the figure we then see in the second column under open door metres per second is the average figure that you took with the anemometer.
Yeah.
Yeah. It doesn't tell us there that it's an average, does it?
No, but that's what it was. That was the average reading per door. And they were the average readings on the grills as well. So again, on the grill, although it was quite small, there was 2 grills, probably took 4 on that, which was 1 shaft.
Yeah.
And then the same, that was the north shaft and south shaft. So where it says high grill, high speed, that's the north shaft. So the average velocity on that grill was per that reading. And then the low grill, high speed, was the average velocity on the other.
Yes, I see. Now, if we can go... Sorry, yes, one final question on this airflow across doors. Did you ever take any airflow readings across any other door other than the stair door at any stage?
No, but when we were doing a certain test, which is the one where we were testing a fire on a floor, then activate the main fireman's override switch, and then what would happen is we'd activate the key switch on that level.
Yes, the yellow key switch.
Yellow key switch. That
Yeah.
would open the dampers on that level.
Yeah.
The fans would start up. We'd open the door, make sure that the fans ramped up to full speed. We'd then close the door, make sure the fans dropped down.
Yes.
I would then take the key switch and I'd go to the floor below. So the dampers are still open.
Yes.
Gary would stay on that floor. I would then open the door to the floor below, into that lobby, and there'd be no airflow. I would then put the key switch in and turn it. I would then tell Gary I've activated the key switch on the next level. He would stay and wait to ensure that all the dampers closed on the level that we'd activated.
Yes.
Then he'd come down to my level.
Yes.
I'd get the key again, he'd stay on that level, we'd do the door function again to make sure the the fans ramped up and ramped down. I would go to the level below.
Yes.
And at no time, when the door on the upper level was either closed or open, when I opened the door to the level below, did I get any airflow?
Okay.
Either inwards or outwards, nothing.
Yeah. I understand. Thank you. Now, the fourth acceptance test is the opening door force. We can see that if we go back to the British Standard RBK 45054, page 73, and we look at paragraph 12.2.4 as the heading opening door force. And if we look below that, it says the fourth acceptance test shall be to measure the opening door force on the doors between the pressurised and unpressurised spaces as defined in clause 4. The opening force at a particular door shall be measured as follows. Then we can see the method described below that. You have to actuate the pressure differential system, fasten the end of the force measuring device, e.g. a spring balance, to the door handle on the side of the door in the direction of opening, release any latching mechanism if necessary holding it open, pull on the free end of the force measuring device, noting the highest value of force measured as the door opens. Now, were you familiar with that method of testing that door opening force?
Yes.
And would you agree that that fourth test required measurements to be taken of all the doors between pressurised and unpressurised spaces?
We tested all the doors that were active fire flow doors. You wouldn't see a force on the door below or above because there's no negative pressure.
I meant the former. Did you check all of the door force
every
openings
floor,
on every single level?
Every floor, and that was witnessed on the first occasion by Max Fordham and J.S. Wrights.
When
they
you
actually
say
took the
witnessed,
measurement.
sorry, just slow down a second.
Max Fordham wanted to see the door opening forces. So we did the door opening force test again with Max Fordham's consultant in attendance, Alan Wright from J.S. Wright, pulled the doors open and took the readings, wrote them down.
Yes. Now, we don't see in the commissioning report, do we, any record of the door opening forces?
Normally, I would have done that and used our spring balance control. Unfortunately, I didn't have it, so Alan went out and bought a spring balance and used theirs, which obviously he kept.
Yes.
And he took the readings, and I asked him for a copy of them.
Right.
I never did get them.
Okay, so what I think you're explaining, and we're going to see this in the email in the moment, is that you didn't have the device for testing the door opening force with you. Is that correct?
Didn't. That's right.
So, but J.S. Wright went out and got such a device, and they did the test, or you did it with them?
No, we did it together. There were three of us. Well, there were four of us.
And how many floors did you do that test on?
All of them.
Every single one?
Every one.
And you expected the results of that to be sent back to you, yes?
Yes.
But
I did ask for them, but I never got them.
But they never were?
No.
No. Yes, let's look at some contemporaneous emails on this. If we go to PSB 401152, we can see an email from David Harrison of PSB to Jonathan Earle at JS Wright. It's dated the 26th of May 2016. And he says, Jonathan, hi Jonathan, following our discussion yesterday and just as a preamble for the smoke control system we have designed to provide the existing stairwell with protection from the ingress of smoke from a fire within a dwelling by means of a mechanical extract system. The system has been designed to provide an average open door velocity across an open stairwell door of 2 metres per second. This velocity is in accordance with the recommendation for a Class B pressure differential system as defined in that Code of Practice 12101 Part 6. And then in the third paragraph it says, the control system also has pressure sensors added into each ventilated lobby to control the speed of the fans to ensure that when the doors on the escape routes are closed, that the opening force on the door does not exceed 100 newtons, as detailed in British Standard 12101 Part 6. This was witnessed by your Mr. Alan White, and the reading, which was not recorded in our commissioning sheets, but read as 85 newtons on the scale provided by J.S. Wright. Do you see that there?
I do, yes.
Now, can we agree that the way that email is written suggests that, in fact, it was only one opening door force measurement which was recorded? He says this was witnessed by your Mr. Alan White, and the reading, which was not recorded in our commissioning sheets, but read as 85 newtons on the scale provided by J.S. Wright. Do you agree that that email suggests that, in fact, only one reading was took at 85 newtons?
Yeah, but as I've said, we did it on every floor.
So I think what you're saying is that's not consistent with what you remember doing, which was actually to test on every floor, yes?
We definitely tested every door, every floor. We started at the top and worked our way down.
Can you help us as to where the 85 newtons comes from?
Well, I think the average that Alan got was about 85 newtons, or the maximum we got was about 85. I previously tested these doors during pre-commissioning, and that's why the fan speeds were changed, so that we got less. We had one or two doors that were like 97. So I changed the fan speed and pressure switch so that it dropped down to about 85. And we did that when I had the spring gauge with me. So I'd already done all these readings once, but the consultant from Max Fordham wanted to see the readings. He also wanted to see the velocity readings, and that's what we did. So we did it on every floor.
Yes. And I think we can see the email where we see Max Fordham wanting to see these readings. If we go to that PSB 401161, page 4, PSB 401161 at page 4. So we can see that this is an email from Alan White, the second one down, from Alan White of JS Wright to David Harrison of PSB, copying in you, 10th of May 2016. And he says, "Good morning, David. We have a few requirements, outstanding items to address to close out Grenfell Tower." And you can see that the second bullet point is Max Fordham's need to see pull tests on each lobby door carried out with fans in low speed to prove we're not exceeding the 100 newtons. This would be satisfied by a schedule of each door and a calibration certificate for the force gauge used. Do you remember reading that?
Well, that's dated 10th of May.
Yes.
Which is after I was on site, but I did those readings with Alan White, and I'm sure the consultant was from Max Fordham, although it could have been somebody from Ryden, I don't know. And we did all those readings.
Yes. I mean, it would appear that Max Fordham wanted a schedule of the readings on each door and a calibration certificate for the force gauge used. Did you understand that's what they wanted?
Well, I can see that now that I'm reading it, yeah.
Yeah. But that was never provided. Neither were provided, were they?
The readings were taken by Alan, and there was somebody else there, myself. All the readings were taken on every floor, and I did ask for a copy, which I never got. As for the calibration certificate, it was just a spring gauge. It was
Right.
a weight, spring gauge weight, basically.
Yeah. If we just move up this chain, if we go to the bottom of page 3, right at the bottom you can see there's an email from David Harrison to Alan White, 11th of May 2016. And then we look at the next page, top of the next page. He says, "Morning, Alan. Please find attached the anemometer calibration certificate for the measured ratings during our final commissioning. Regarding the other points, Granville has been trying to contact you on numerous occasions to discuss in detail. So if you give him a call, it would be appreciated." So had you been trying to contact Alan White to discuss this point about the force opening, the door force opening?
That email is in the context of the grill velocities. The building control had asked could they have volumetric readings for the doors rather than a velocity, but the spec requests velocity, not volumetric. So I asked Alan if he sent me the area of each door, I would work out the volumetric reading in metres cubed per second rather than metres per second.
Yes.
And no, he never answered any of the requests.
I see. And if I can just finish just looking at this email chain, if we move up the chain on page 3, a few lines down from the top of page 3, We see Alan White then emailing PSB, including you, so emails David Harrison and your seed, asking for PSB's availability to carry out door pull tests and for the airflow readings requested by building control. So he says, David, to satisfy building control and the consultant and close out this job in your help with the points below, building control, I think that should be 1, measured flow rates at each high and low damper done with hoods and not calculated from the velocity versus free area. The consultant wants proof that each door does not exceed 100 newtons of pull force. Do you see that there?
Yes, I do, yeah.
And then, Mr. Chairman, actually I have to go to a new email string there.
Would you rather come back to that later?
Yes, I think let's break there. I can carry on with this topic perfectly happily after the break. Yes.
All right, well, we'll
Thank
stop
you.
there then. Well, Mr. Partlow, it's time we all broke to have some lunch. So we'll do that now. We'll come back, please, at 2 o'clock. And again, please don't talk to anyone about your evidence or anything relating to it while you're away from the room. All right?
Yep, no problem.
Thank you very much. If you'd like to
Okay.
go to the usher then, please. Thank you very much. 2 o'clock, please.